So this video is going to go over circle theorems. Now you're either watching this video because you're revising or because you're trying to learn what the circle theorems are. So if you're somebody that's watching this just for revision, what you might want to do is to look at the theorem here, pause the video and see if you can come up with the theorem by yourself before I write it in, and then play the video to check that you've got it correct. Obviously, if you're watching it because you don't know the theorems, then I would just maybe draw these out while I'm going through it and make a note of them. So the first circle theorem here, and these don't have to be in this particular order, this is just the order that I've chosen to put them in, but they can be in any order. So this is not known as like circle theorem 1, so when I call it the first one, it's not officially known as the first one. So this one here, you can see that we've got a diameter going across the circle because that there is the centre, and quite often in circle theorem questions the centre is marked with an O like that. Okay, so you need to make sure that you see that centre to assume that that's a diameter. So if you just see a circle like this and it looks like it's going through the middle but the centre isn't actually marked on, you cannot assume it's a diameter. Okay, so that centre definitely needs to be marked on. And when you have a diameter, that obviously splits the circle into two halves. You've got this half up here and then you've got the half down here. So we know that half a circle is called a semicircle. And the angle here at the circumference in the semicircle is always a 90-degree angle. So if I pick the ends of the diameter and I decide to join them up, say over here, like this would also make a 90-degree angle, and likewise I could have gone down in this segment down here, and that would make a 90-degree angle. So the angle, wherever I join up the ends of the diameter, the angle there opposite the diameter is always 90 degrees. So what you'd have to write in the exam is the angle at the circumference in a semicircle is 90 degrees. That would be fine. Okay, the next one is usually quite nice to remember. Most people are able to spot like the arrow kind of shape here. And this one is at the angle here at the centre. So again, that hasn't really come up very well. So we'll make a nice point of the fact that that again should be marked on. I'm going to call it O just because in the exam that's quite often what they do. So the angle there at the centre is double the one at the circumference. So just as an example, if this one was 120, then this one would have to be 60. So likewise, if you're given this one, you can double it to get the angle here at the centre. So again, quite often in an exam, they might say if this one's 60 to say what angle X is, and then you have to give your reasons. So you do need to know these theorems off by heart. So the theorem for this one is the angle at the centre is double the one at the circumference. Sorry, my writing is really messy, it's because I feel pressurised to do this quickly. At the circumference. Okay, next one is fairly easy to recognise in the exam. We've said before that these look like mountains. So likewise, if you turned it around, you've obviously got the mountains up here as well. So that's what you can use to help you spot that. But again, you're only going to get one mark really for saying what the angle is, and the other mark is going to be for the reason. So when you've got 2 points like this, it makes, if I join them up like that, it makes a chord. And you've got the bigger segment here above that chord, and then a smaller segment underneath it. Now, where I join the 2 ends of the chord up, if it's in the same segment, so you can see both of these are in this bigger segment here, above the line, these angles therefore are at the circumference are the same. If I join them up down here in the other segment, this one wouldn't be the same as that one because this one is in the smaller segment underneath that chord that I drew in, and this one here is in the bigger segment, so they wouldn't be the same. However, if I mark that angle on now, if I join these ends up again somewhere in the smaller segment, so say if I go now over here, like that, then those two angles would be the same. So they need to be in the same segment. So the theorem is angles at the circumference in the same segment are equal. Right, the next one, I always quite like this one as well. Most of you are quite aware of the fact a four-sided shape is called a quadrilateral, isn't it? So a shape with four sides is a quadrilateral. Now, when all 4 points, so 1, 2, 3, 4, like that, are on what we call the circumference, the edge of the circle, it's called a cyclic quadrilateral. I've got to spell this now, haven't I? Cyclic, I missed the C, hang on, there we go. Cyclic quadrilateral. Okay, and you need to make sure that all 4 points are on the edge. Now, when you watch the next video about circle theorems, we'll do some more examples, and I will show you examples where all 4 points aren't on the edge. And quite often people do this question incorrectly because they've just assumed it's a cyclic quadrilateral. So all 4 points, always just go 1, 2, 3, 4, check they're on the edge before you start to use this theorem. So they've marked on these two angles. Now you can see from looking at it, this one is an obtuse and this one is an acute angle. So they're not going to be the same, but the opposite angles in a cyclic quadrilateral. Now I'm going to cheat and just put CQ here. You can't do that in the exam, but I've written it up there to save time. So I just put opposite angles in a cyclic quadrilateral add up to 180 degrees. So if in the exam they said this one here is 110, what's this one? And give your reason, it would be that if this one's 110, this one would be 70 because they add up to 180. And your reason, you can't just say because they add up to 180, you have to say because opposite angles in a cyclic quadrilateral add up to 180 degrees. Okay, this is the last of the complicated ones. This one's really easy. So this one here, first of all, just a few lines that you need to know the names of. So when you've got a line from one side of the circle to the other and it hasn't gone through the middle, so it's not a diameter, it's called a chord. And this line here where it touches the circle in one place is called the tangent. Now the angle between the chord and the tangent, so this angle here, is the same as when you join up the ends of the chord to the circumference up here. Okay, so these two angles are going to be the same. Now this one has got a nice name for it, so alternate segment theorem. So it's not as wordy as the others actually. The only thing with this one is that it's a lot trickier to spot in the exam. So it's the alternate segment theorem, so that is the chord and the tangent. So likewise, this line here is also a chord, isn't it? So from here to here, that's also a chord, and that's still the tangent. So this angle here, if I join up the ends of the chord, they're going to be up there, so it would be the same as that angle up there like that. Okay, so those angles would be the same, and in the exam it's enough to just say because of the alternate segment theorem. Right, the final one is that this is again a tangent, and this line here is a radius. And quite clearly you can see it on here, it's kind of done the theorem for you. You would have to say the angle between a radius and tangent is 90 degrees. Now the other thing, it's not really so much a theorem, but just something I just want to point out to remember with circle theorem questions. If that centre is marked on, remember that that line is called a radius, and I could draw a radius anywhere else on that circle. I could come out over here for example, and that would also be a radius. And so when they're joined up like that, you then get an isosceles triangle, because if that's a radius and that's a radius, they're going to be exactly the same length. So you just need to watch out for isosceles triangles, but again, make sure that centre has been marked on before you assume it's a radius. So even if you've got a triangle that looks like this, and it might look isosceles, if that hasn't been marked on as the centre, you cannot say that that is the same as that, because it hasn't been marked on. You don't know for sure that that is a radius. Okay, so just look out for where that centre's been marked on, and then you will get a radius there and a radius there. Okay, so what you really need to do now is to watch the next video, so Circle Theorems 2, and that will give you some examples of how to use these theorems.